Quick revision video on intermolecular forces. So some essentials. These exist between molecules of simple covalent substances. So some examples there: iodine, methane, water and glucose. They don't exist between giant structures. So ionic substances, giant covalent and metallic substances don't have intermolecular forces. It's only between molecules of simple covalent substances. There's three types: induced dipole-dipole force or London dispersion forces, permanent dipole forces, or hydrogen bonds. We'll look at each of those in turn now. So starting with induced dipole-dipole or London dispersion forces. So at any instant the electron density in a molecule is uneven, and that causes an instantaneous or temporary or fluctuating dipole in the molecule. So if you imagine this molecule here, at the instant that this has been taken, slightly more electron density on the right hand side of the molecule than the left, and that gives an instantaneous dipole, slightly negative on this end, slightly positive on that end. So if you bring in a neighbouring molecule now, that electron density skewed to the right there will repel the electron density in this molecule over to the right. So that's going to induce a dipole in a neighbouring molecule. And because you've got opposite ends of dipoles next to each other, so you've got a delta plus on this one next to a delta minus on that one, you can have an attraction between the molecules, and that's your induced dipole intermolecular force. As the number of electrons increases in the molecules, these instantaneous and induced dipoles get stronger, and therefore the intermolecular forces get stronger. And finally, these intermolecular forces occur between all molecules, but it's the only intermolecular force between non-polar molecules. Obviously, all molecules have this force because all molecules have electrons. Moving on to permanent dipole. So these occur between polar molecules, in other words, molecules that have a permanent dipole. So an example of that would be HCl, hydrogen chloride. So we've got a permanent dipole in the molecule because chlorine is slightly more electronegative than hydrogen, and so therefore this chlorine would be slightly negative and the hydrogen would be slightly positive. So if you bring in a neighbouring molecule, there's obviously going to be an attraction between these two dipoles, and that's the intermolecular force. As the permanent dipole gets stronger, so as the electronegativity difference gets bigger between the two atoms in the molecule or in the bond, the intermolecular force will increase. And just a reminder that you'd still have London forces or induced dipole forces between these molecules. Hydrogen bonds now. So this is a special type of permanent dipole intermolecular force. It occurs between polar molecules that have a hydrogen directly bonded to a highly electronegative fluorine, oxygen or nitrogen. So examples of molecules that have this intermolecular force between them is hydrogen fluoride, water, alcohols, because you've got an OH bond in the alcohol, carboxylic acids, again you've got an OH as part of the carboxyl group, ammonia, and amines, because you've got a nitrogen directly bonded to a hydrogen in amines. So what's happening in hydrogen bonding is the lone pair of the highly electronegative atoms, so the fluorine, the oxygen or the nitrogen, is attracted to the slightly positive hydrogen of a neighbouring molecule. So if we think about water, got a lone pair on that oxygen and a neighbouring water molecule, so the delta plus hydrogen on the neighbouring water molecule will be attracted to the lone pair on the oxygen. So when you're answering exam questions, you often have to draw a diagram. Make sure you include the dipole in the polar bonds, the lone pair on the electronegative atom, and the hydrogen bond must go from the lone pair to a neighbouring hydrogen. And of course you're still going to have those London or induced dipole forces. So we'll finish with the relative strength of the three types of intermolecular force. So in general, hydrogen bonds are the strongest, permanent dipole are the intermediate strength, and induced dipole are the weakest. However, if you've got a large number of electrons in a non-polar molecule, they can actually make the induced dipole forces stronger than the other two.